Welcome to this explainer. Today, we're stepping right into the middle of a literal deep space forensic mystery. If you look up at the night sky, it's so easy to just assume that all those galaxies drifting out there in the cosmos are as serene and quiet as they look. But when we actually look closer, when we peel back the layers using multi-wavelength data, we usually uncover these chaotic, incredibly turbulent histories hiding just beneath the surface. And honestly, that is exactly what we're going to do today as we unravel the mystery of an absolutely incredible galactic puzzle. Okay, let's just dive right into this. We're going to anchor our investigation on a deeply fascinating cosmic target. We're looking at NGC 533, which is a galaxy located about 65 million light-years away from us, right in the Canes Venatici constellation. Now, from a distance, this galaxy poses a simple but really profound question. What exactly is lurking inside this seemingly quiet spiral? Because, as we'll see from the data, it's harboring some major secrets that totally challenge our understanding of how these types of galaxies actually operate. So, to really grasp this mystery, we first have to establish our baseline. On the surface, if we look at its optical structure superimposed with some molecular gas, specifically carbon monoxide, NGC 533 presents as a perfectly standard, undeniably beautiful spiral galaxy. I mean, it's got a pronounced spiral structure, a nice central stellar bulge, and it just looks incredibly peaceful. But that peacefulness is basically a lie. It completely belies the chaotic, multi-wavelength reality that is actually churning underneath. This picturesque surface, it's essentially the galaxy's alibi. Right, so to crack this case, we need to talk about what a Seyfert galaxy actually is, because deep inside that quiet little spiral we just discussed beats a ravenous, highly active heart. NGC 5033 isn't just your run-of-the-mill spiral, it's a Seyfert 1.5 galaxy. And Seyferts are this specific class of galaxies that feature these ridiculously active, luminous centers powered by supermassive black holes, which astrophysicists call an active galactic nucleus, or AGN. Finding this active, feeding monster inside our seemingly peaceful spiral is really the core of the paradox we're looking at today. But here is where the galaxy's anatomy just doesn't make sense. For an active galactic nucleus to glow that brightly, it absolutely needs a steady diet of gas. Usually, nature provides a neat little delivery system for this fuel, typically in the form of a large-scale galactic bar, basically a physical structure of stars and gas that funnels materials straight into the galaxy's center. But here's the reality of NGC 53. The data confirms it has absolutely zero large-scale bar. None. Even stranger, there is an actual depression, a local minimum, of molecular gas right at the very center where all this fuel should be piling up. So how on earth is this black hole feeding? Well, by analyzing the molecular gas distribution, specifically by mapping the carbon monoxide, we can literally pinpoint the problem. The analysis clearly shows a really strange depletion of gas, exactly where the feeding frenzy of the active nucleus should be happening. The gas is distributed perfectly fine throughout the rest of the spiral, but right there in the inner kiloparsec, there's a distinct, undeniable lack of the dense fuel we'd expect to find feeding a Seyfert nucleus. We've got to ground these observations with some hard numbers to truly appreciate the sheer scale and physics at play here. This galaxy we're investigating is actually receding from us at an astonishing velocity of roughly 875 kilometers per second. Just try to wrap your head around that speed for a second. We are talking about a massive, highly dynamic system that is just tearing through space. And understanding its kinematics like this is absolutely key to understanding its hidden internal engine. So this leaves us with a totally fascinating trail of forensic clues scattered throughout the data. I mean, if a large-scale bar isn't funneling the gas, then what is? We have this incredibly compelling list of asymmetrical irregularities. There's a biconical structure of high ionization, a heavily asymmetrical intensity map of ionized oxygen, and, of course, that bizarre local minimum of central gas we just talked about. But you know what the most glaring clue is? The Seyfert nucleus itself is completely off-center relative to the stellar rotation center. That is a massive red flag. It proves that something fundamentally asymmetrical, something violently external, is pulling the strings here and creating major departures in the galaxy's gravitational field. Now, while that central black hole is mysteriously getting fed, the surrounding central region is far from quiet itself. When we interrogate the intense starburst activity happening in the circumnuclear region, we find an incredible rate of massive supernova explosions. Based on the far infrared and radioluminosities, scientists have calculated that a massive star explodes as a supernova in this region roughly once every 22 years. I mean, in cosmic terms, that's not just active, that is an absolute non-stop fireworks display. And those explosions definitely leave a mark. The sources paint a super vivid picture here. They describe this fluffy envelope of radio emissions sitting right in the central region. Think about it. When you have sequential supernova explosions going off in one concentrated area, they literally blow these massive hot super bubbles. These bubbles expand and eventually just pop directly out of the galactic disk, shooting radio-emitting relativistic electrons out into a halo around the core. So this seemingly quiet spiral, it's actually boiling from the inside out. The physical distortion of the entire galaxy becomes totally undeniable when we examine the neutral hydrogen data for NGC 5033. We see this massive, highly asymmetrical plume of hydrogen extending a staggering 6 kiloparsecs out to the south of the galaxy, with literally no matching structure on the northern side at all. Plus, the velocity field reveals that the galactic disk itself is heavily warped at its edges. Guys, this is the smoking gun. You just don't get massive, one-sided gas plumes and severely warped disks without some kind of massive past gravitational disturbance. Something truly huge tugged at NGC 5033. Well, to find our culprit, we really just need to check out the neighborhood. Enter NGC 5005. This is another massive Seyfert galaxy located just 139 kiloparsecs away. Their velocities are incredibly close, which makes them a definitive physical binary pair in space. So our supposedly quiet, solitary little galaxy isn't floating out there all alone after all. It actually has a giant, highly active neighbor. This changes everything. It means NGC 5033 is firmly locked in a gravitational dance with this massive partner. The tidal forces from this cosmic interaction, that's our unseen hand. Those forces are stirring the gas. They're creating that heavy warp in the outer disk. They're pulling that massive southern plume of hydrogen out into the void, and they are destabilizing the central gas just enough to fuel that Seyfert heart, all without ever needing a traditional galactic bar. And that off-center nucleus we flagged earlier, it's highly indicative of a past merger or a severely close encounter with this neighbor. When we synthesize all this data, combining the continuum observations with the neutral hydrogen density, the entire mystery just unravels beautifully. The data confirms the total lack of a large-scale bar in the center, while clearly exposing the warped, stretched reality of a system undergoing mildly destabilizing galactic interactions. The fuel is getting to the black hole, but not through some smooth, structured pipeline. It's getting there through the sheer gravitational shaking caused by a massive binary companion. So, as we wrap up this cosmic detective story, I want to leave you with a somewhat provocative thought. NGC 5330 looks exactly like a textbook, totally undisturbed spiral galaxy in standard optical light. It was only by digging deeper, looking at the molecular gas, the neutral hydrogen, and the radio emissions, that we uncovered superbubbles, asymmetrical plumes, off-center black holes, and this invisible gravitational tug-of-war with a massive neighbor. It really makes you wonder, doesn't it? When you look up at the night sky, how many other seemingly quiet galaxies are actually hiding turbulent, violently beautiful histories of cosmic interactions? Thank you so much for joining me on this explainer, and keep questioning what you see up there.